Good morning, students. This is Sandra Devi, working as Assistant Professor in Department of Mechanical Engineering and College of Engineering and Technology. In this session, we are discussing about the powdered rapid prototyping system. In this powdered rapid prototyping system, there is only one type of process which we are taking. That is a selective laser sintering technology. It is nothing but SLS process or SLS rapid prototyping process. Okay, in this selective laser sintering process, we are discussing about how the 3D models will be injected through the laser beam systems and how the product are giving the output mechanism throughout the life cycles. Okay, this selective laser sintering process it is a rapid prototyping process that build models from a wide variety of materials using an additive fabrication method. Okay, the build media of our SLS comes in powder form, which is fused together by a powerful carbon dioxide laser to form the final product. Okay, this SLS is one of the rapid prototyping processes which can be used in an additive fabrication methods. Additive fabrication method means which we are giving the additional process to the product. Okay, and it is which is fused together by a powerful carbon dioxide processor. Okay, the selective laser sintering process was developed by the University of Texas. Okay, the filled media for SLS comes in powder form, which is fused together by powerful carbon dioxide laser to form the final product. SLS currently has 10 different build materials that can be used within the same machine for a wide variety of applications. The SLS process begins like of most other rapid prototyping process with the standard STL CAD 5 format, which is exported now by most 3D CAD packages. Okay, the SLS form has a moving laser beams. See, it has a moving laser beams which is used with an a mirror type, and that geometric model will be moved over the 3D part geometry areas for not sintering the powders for not loose can be poured out of completed area. Okay, if you see in this diagram, it is in a three images can be scanned throughout the system. So, if you see in the first image, it is on a base material which we are taking. In this base material, I am taking one form. It is in a powder feed form. Okay, this powder feed form will be mashed into a fine particle. So, how the powder leveling roller will be injected. Okay, the powder will be slightly injected throughout the area which we are taking in this area can be formed, and the temperature controlled build chamber with nitrogen atmosphere will be scanned throughout the system material. And next one, if you see that the carbon dioxide laser system which can be easily built part throughout the powder bed on a build position, and excess powder take up will be taken from throughout the material systems. And this carbon dioxide laser will be injected throughout this build part, and then the powder will be leveled throughout the surface of the material. Then only the powdered material will directly converted into the SLS form, and by the rolling system it will be rolled throughout the bed material. Okay, bed material, and this scanning system also can be formed, can be identified when the material is not smooth enough, and the material is not smoothed throughout the material system. Okay, the temperature controlled build chamber with nitrogen atmosphere can be easily identified throughout the system material. Excess powder take up throughout the material of the injector systems. Next, and this SLS mechanism can be easily identified through system materials and also will be injected throughout the materials. And this is the laser scanning methods. If you say this is the bed material. Okay, this is the base material. From this base materials, we put the powdered materials, and the powdered materials are injected into the bed material, and this laser scanning direction will be indicated throughout the systems of the projected areas. And this sintered powdered laser beam laser sintering pre-placed powder bed green state unsintered material into the previous laser. When this bed material are directly injected through the systems, The laser scan and direction will be projected through the powdered material. Then this powdered material will be chopped into a fine materials, and then the product will be injected. Okay, material that can be used: plastic powders, metal powders, direct metal sintering, ceramic powders, and glass powders. Next, and this SLS can be stronger than SLA. Sometimes structurally functional parts are possible, and the variety of the materials and the ability of approximate common engineering plastic materials can be easily identified throughout the systems. Okay, and next, see, if you see in this image, this is the roller system. This is the powdered based system, and this powdered based system will be injected through the laser beam system. This roller part will be chopped into a fine materials, and to place the craft material throughout the system of the throughout the product. Okay, and next the object fabricated will be directly injected to the fabrication piston, and this fabrication piston will be scanned throughout the laser beam materials, and this laser beam materials will be directly powdered by the powder deliver system, and then the product will be come out. Okay, if you see in this image, this is all the powder paste rapid prototyping system, with which the layers we can form by powdered RP systems. Okay, next surface finish. Surface finish. The surface of an SLS part is a powdery like the other base materials whose particles are fused together without complete melting. The smoother surface of an SLA part typically wins over SLS when an appearance model is desired. In addition, if the temperature of uncured SLS powder gets too high, excess fused materials can collect on the part surface. This can be difficult to control since there are so many variables in this SLS process. In general, SLA is a better process where fine, accurate detail is required. However, a varnish-like coating can be applied to SLS parts to seal and strengthen them. Okay, surface finish is very important in this material, so because of the surface is of an SLS part of a powdery system with the base materials. Okay, in addition, if the temperature of uncured SLS powder gets high, excess fused materials can be collected throughout the part surface. In general, SLA is a better process where fine, accurate details is required, and this surface finish will be directly injected into this powdered-based rapid prototyping system, and then the powder will be melt into this fine powder piston, and that piston will be directly injected through the systems. Okay, next dimensional accuracy. Dimensional accuracy is nothing but SLA is more accurate immediately after completion of the model, but SLS is less prone to residual stresses that are caused by long-term curing and environmental stresses. The temperature dependence of the SLS process can sometimes result in excess material fusing to the surface of the model. SLA parts suffer from the trapped volume problem, in which cups in the structure that hold fluid causes inaccuracies. This SLA is more accurate of the model, but SLS is less prone to residual stresses, means which the stresses is available in this powdered system can be highly rejected throughout the long-term curing and environmental stresses. The temperature dependence of the SLS process can sometimes result in excess material of fusing to the surface of the model. Next, support structure, structural accuracy, structural method, dimensional accuracy, support structures. SLA parts typically need support structures during the building. SLS parts can because of the supporting powder sometimes does not need any applications due to the depend upon the part configuration. And next, data preparation for SLS. The SLS technology is housed in the centralization line of systems by JPM. The current model is the centralization 2500, which has various improvements over its predecessor. If you see in this image, this is one of the type of this sintering process machine, which will be directly given by the program. Okay, if we given the program automatically by taking this program, it will be throughout the product will be measuring into this machine, and then it comes out of the product. Okay, and this current model in the centralization which has various improvements in this synchronization process. The SLS process begins like most other rapid prototyping process with the standard STL graphical format, which is exported now by most 3D CAD packages. The DTM view software can import one or several STL files and allows you to orient or scale the part as you see necessary. Okay, the 2500 systems have auto nesting capabilities which will place multiple parts of the systems. Okay, and this is the experimental setup and working process. Okay, with the built piston at the top of thin layer of a powdered is spread across the built area by a roller sweeper from one of the feed pistons. The laser then fuels in a raster sweep motion of the area. See, this is the SLS process which we are taking throughout the system. Material will be directly injected into this material, and then with the help of the roller, it throughout the smoothen the materials, and then it will be projected directly to the laser beam systems, and then the product will be appeared. Okay, in this powdered rapid prototyping system, the most important thing is the powder should be very fine materials. Then only the product will be appeared neatly, and how the braking systems also can be easily defected throughout the system materials. And this powdered based materials will be very high accuracy, and also the strength materials and the dimensional accuracy surface finish will be directly projected throughout the system of the materials. Okay, and this Celestia will be having a 3D prototype material systems throughout the projected area of the system materials, and this highly experimental systems will be directly injected through this STL files, and this STL files will be stored into this system, and then with the help of the programming format, that will be injected slowly to the atmospheric positions. Okay, the DTM view software can import one or several STL files and allow you to orient or scale the parts as you see necessary. The 2500 systems have auto nesting capabilities which will place multiple parts optimally in the build chamber for the best processing speed and results. One of the STL files are placed and processing parameters are set the models and built directly from the file. And this data preparation of SLS process will be highly projected throughout the system materials. And then the technology is housed into this centralization line of systems by keeping the DTM process. Okay. See, in the first unit you have discussed about the rapid prototyping systems, several types of rapid prototyping systems. First, what is meant by additive manufacturing? Additive manufacturing is nothing but we are giving the additional material. If you are taking one product, suppose if you are taking one doll, okay. If you have addition materials to the doll, the additive manufacturing process is very important. Additive manufacturing is an all fabrication process or all manufacturing process will be availability in this additive manufacturing process. You will do manufacturing, you will do production, you will do fabrication, you will design the materials. Okay, and that all the materials will be added into this additive manufacturing systems. And this additive manufacturing systems, you will be appeared with the 3D systems. Okay, in that additive, after that additive manufacturing, you will take that prototyping systems. Means rapid prototyping systems. Rapid prototype means we are giving with the help of the another materials to be added to this material. Means laser beam systems or like that. The rapid prototyping systems will be highly appeared or highly affected through these systems. This is called as a rapid prototyping system. In this rapid prototyping system, there are three parts. One is a liquid-based rapid prototyping system, solid-based rapid prototyping system, powder-based rapid prototyping system. Liquid-based rapid prototyping system, there are three parts. First is SLA process. Next is deposit manufacturing process, and also solid curing rapid prototyping systems. There are three types. In these three types only, there are very important how the 3D models will be directly projected through the area. And this solid based rapid prototyping system also, you will find out the FDM process and DDM process. This is fused deposit manufacturing process. Okay, how what is the difference between these all means how the materials can be manufacturing through the protected area of the systems will be identified throughout the materials. Okay, this is the difference between the this is the difference between the manufacturing rapid prototyping systems, and also how the technology will be directly injected to the laser beam systems will be highly recommended throughout the material process. Okay, these are the prototyping systems. These are the prototyping systems of the highly protected area of the materials. Okay, and this is the support, and this is the SLS process that we have discussed in the last class, and this class also we revised once more in this SLS. In the third unit, you will discussed about only about the powder-based rapid prototyping system. Okay, powder-based rapid. In this powder-based rapid prototyping system, you will know about how the SLS process will be directly converted into 3D models and how it will be injected. Okay, and you will learn about the 3D model systems, 3D model system, and about the case studies, how it defects throughout the system, and how the different types of structures will be formed throughout this SLS process. Okay, next, and this SLS process will be directly given to the different types of machines, and it will be directly injected into this plastic powders and powder delivery systems with the help of the roller and the laser beam systems. Okay, this is the fabrication powdered bed materials and the terms which we are used in the powder-based rapid prototyping system. In the scanner system, object being fabrication powdered bed, laser, roller, powder delivered systems, powder delivered piston, fabrication piston. Okay, if you are how the powdered waste will be available in the materials is laser scanning direction, sintered powdered process, laser beams, laser sintering process, pre-placed powder bed degree systems, and unsintering material is per the previous layers, which will be directly injected into this 3D processing materials. Okay, and these processing materials will be highly recommended through the system materials which will be injected through the materials, and this powder delivered system will be rolled, and through the fabrication system it will goes downwards, and then the fabricated material will be highly recommended, and this fabrication powdered bed will be powdered throughout the system materials, and how the laser beam scanning systems means laser beam scanning system will be through the electrical purpose the laser beam direction will be given. Okay, and this centering, and it will be very easy to find the materials throughout the system materials. Okay, and this is the sintered powdered particles will be highly fabricated through the powdered materials. The pre-placed powdered bed materials will be scanned throughout the system materials. The object being fabricated materials will be powdered throughout the roller systems, and the laser beam systems will be fabricated through the materials. Okay, and this processing will be injected throughout the materials of the processing materials. Okay, in this material that can be used is plastic powders, metal powders, and ceramic powders, and glass powders. Okay, glass powders, and this SLS mechanism with the help of the scanning system and carbon dioxide laser beam system. So the temperature controlled the build chamber with the nitrogen atmosphere. The powdered level roller be fed to all the system materials, and the powder feed the materials to the powder bed to the build position, and excess powder will be taken up throughout the materials of the scanning systems. The temperature controlled build chamber with the nitrogen atmosphere and powder level mechanisms will be highly indicated throughout the system materials. And this carbon dioxide laser beam systems will be help with the rapid prototyping systems. The temperature controlled build chamber with the nitrogen atmosphere, powdered leveling roller, powder feed roller will be built throughout the system materials. The powder bed on build position will be thoroughly tempered to the build chamber of the nitrogen atmosphere, and the powder feed materials will be build part through the positions of the excess powder will be taken up. The piston will be directly injected into these materials through the scanning systems of the materials. The carbon dioxide laser beam mechanisms will be tempered through the build chamber with the nitrogen and also the atmospheric materials, and this moving laser beam can be sintered with different types of areas of the CAD geometric model of one layer at a time to build the solid part. After each layer is completed, a new layer of loose powders is spread across the surface, and layer by layer the powders are gradually bonded by the laser beam into a solid mass that forms to the 3D geometric part of the geometric model. The build media for SLS comes in powder form, which is fused together by the powerful carbon dioxide laser to form the final product. SLS currently has 10 different build materials that can be used within the same machine for a wide variety of applications. The SLS process begins like most other rapid prototyping process with the standard materials. Okay, standard materials. And this laser sintering process was developed by the universities of Texas and was commercialized by DTM Corporation of materials. The SLS processor begins like most other rapid prototyping process with the standard STL CAD file format, which is exported now by most 3D CAD packages. Okay, the 2500 systems have auto nesting capabilities, which will place multiple parts optimally in the build chamber for the best processing speed and results. Once the STL files are placed and the processing parameters are set, the builds are built directly from the file. The SLS means Selective Laser Sintering Rapid Prototyping Systems. Okay, and this will be highly through the STL file, which can be directly injected into this file, which will be highly throughout the system materials of once the STL files are placed and processing parameters are set, the models are built directly from the file. And also the DTM process and SMS technology is housed in the synchronization lineup of systems by DTM. The current model is the Synchronization 2500, which has various improvements over its predecessor, the synchronization process. And also the different types of STL plus and the support structures. will be throughout the SLA parts typically need support structure during the build. The SLS parts, because of the supported powder, sometimes do not need any support, but this depend upon on part configurations. Marks left after removal of support structures for parts cause dimensional inaccuracies and cosmetic blemishes, which is directly projected into the SLA and is more accurate immediately after completion of the model. But SLS is less prone to residual stresses that are caused by long-term curing and environmental stresses. The temperature depend upon the SLS process can sometimes result in excess material fusing to the surface of the model. SLA parts suffer from the trapped volume problem, in which capsule structure data hold fluid cause inaccuracies. The SLS parts do not have this problem. Okay. This is the different types of and a different process of this SLA processor, which will be supported powdered sometimes and not need any support, but this depend upon the configurations of the materials. Okay. And in this and up to now we have discussed about the three units. Okay, already I have told us. First unit is a rapid prototyping system. Second unit is solid based rapid prototyping system. Third unit is powder based rapid prototyping system. In Google Drive, I will keep the materials of the 6 unit. Once you go through the Google Drive, and I will keep the important questions and also syllabus also. You go through the syllabus and you will know what are the concepts we are having in this additive manufacturing process. Okay, it is very easy subject, which we can be easily scored in your this semester. And also this process also is very easy. We can understand very easy, and only by using the 3D models we are modifying one of the rapid prototyping systems into different materials or a different process. Okay, and this process is how we are taking in different materials and different process. We are discussing about that process, and we are discussing about different types of case studies. How the differences will be taken into this materials. Okay. Once we go to the Google Drive, I will keep all the 6 unit materials in the Google Drive. Okay. We will see in the next class, students. Thank you.